Breaking records is something that mankind loves doing. But have you ever thought, what will happen if we break the highest record there is in our history? Let's dig deep today and find out what will happen if we ever reach the speed of light by the end of the decade. We humans definitely love competition, right? I mean, just look at our entire history. We have ventured into wars for power and for territory. We developed sports in the Olympics. We have developed competitive gaming. And if those weren't competitive enough, we even have contests for eating. These examples tell us that proving we are better than another entity is something that is genetically embedded in us and helps us develop our own kind of better in more ways than one. Now, combining that with our insane curiosity, see what I did there? We have come to one of humanity's greatest endeavors in recent memory, reaching the universe's ultimate speed limit, the speed of light. Whatever the main reason is, traveling in the speed of light has been one of fiction writing's favorite bread and butter, from the Millennium Falcon's jump into hyperdrive speed in Star Wars to DC's beloved speedsters in the Flash universe. Writers all over the world definitely share this common fantasy of us as a species reaching light speed. So what's so special about reaching this level of speed? Now let's take that up a notch. What's so special if we ever reach the speed of light by the end of the decade? Do we finally get the cure for cancer? Do we finally end all wars and achieve world peace? Does global warming end instantaneously? Well, we're not really sure, but who knows? There could be an overlap where our ingenuity causes us to solve all of these upon the discovery of speed of light travel. Easily the most obvious answer is that we can travel farther into the universe since we can move faster. The farther we can travel, the more we will know and eventually understand about the universe. Just for a bit of perspective, let's start with a very familiar example. Something as common as the light from the sun reaching the Earth. If you listen to your elementary astronomy, or in any out-of-the-pocket science outlets out there, you probably have already heard that light needs more or less 8 minutes to reach our home planet. And that's not an easy distance to cover. The average distance of the sun to the Earth is around 149 million kilometers, or 92.3 million miles if you're one of our friends from the USA. Now imagine if the world's fastest land vehicle, the Thrust SSC, was set on an adventure to do one trip from here to our own star. Don't be a killjoy, let's just assume that it is possible, okay? Even at its supersonic speed of 1,028 kilometers per hour, it would take around 14 years just to get there, meaning 28 years for a round trip. A baby could be born at its launch date and become a fully grown office worker by the time it gets back. Traveling at light speed, on the other hand, can do that with ease just around the time you finish that video. Let that craziness sink in for a minute. Remember the Mars probes that arrived at the Red Planet just this past February? That journey took them almost a year, but if they are moving at the speed of light, that journey would have just taken roughly around 3 minutes. That will accelerate a lot of our upcoming missions to Mars as well, and development of the technology needed for our endeavor of conquering the Red Planet will speed up by a colossal scale. We could be building our colonies as early as next year. Now that may sound like we're experiencing a gigantic FOMO in terms of exploring the universe, but we're literally at a time limit in our quest in getting to know what's out there. Through the efforts of one of our biggest heroes in astronomy, Hubble, it was established that our universe had been constantly expanding. It's easy to think of just waiting for the day when we can finally reach far things in our universe with our current technology. I mean, we human beings are ultimately ingenious after all. Developing this kind of technology shouldn't be too far out in the future, right? That may be the case, but the rate at which the universe expands is several times faster than the speed of light. Remember how Einstein's general relativity established how space and time is actually one and the same sheet, and that everything runs through this? So it simply makes sense that if the material should expand faster than anything that's on it, for lack of better terminology. Having said that, if we don't explore the universe fast enough, eventually everything else will be so far away that there will literally be no stars or planets or anything to observe. All of the other objects in our universe would be several magnitudes away from us, that on that day we will have no other choice but to believe that we are the only planet in the whole universe. That is assuming our civilization will make it to that point, of course. You know, with the inevitable swelling up of the sun and everything. Typical space-related ending points. Okay, enough about depressing stuff. So what else happens when we reach the speed of light? If you're a fan of wellness and keeping your youth, this next item is definitely going to be interesting for you. Another thing we can accomplish if we reach the speed of light by the end of the decade is that we can slow down aging to the highest extent. So where were we? All right, slowing down aging. At this point, we're not going to discover some cosmic facial cream or some divine serum that we can inject just because we reached the speed of light and we made contact with some eternal businessmen selling beauty products. More than biology and chemistry, all we're going to need is some nice old astrophysics. Einstein's special relativity tells us that the ultimate speed limit of the universe, and moving at this pace, generates wild effects. Particularly if you somehow manage to reach running this fast, your length contracts, your mass reaches infinity, and time slows down for you. Now I'd like you to take note of that last bit. Remember how we mentioned earlier that the paradigm of time being the ultimate standard for anything in the universe was replaced with a new one in the advent of establishing the speed limit of the universe as the speed of light? This ties up to that. Believe it or not, this has already been demonstrated, or rather imagined, in a thought experiment called the twin paradox. Just a quick recap for anybody who's not familiar with this thought. So say we have identical twins named John and Johnny. Johnny decides to become an astronaut and goes to space for a mission that will take him around 20 years Earth time. Now, of course, we don't expect Johnny to be riding aboard a rocket that moves at a slow pace. The rocket's going to be moving at a fraction of the speed of light. Keeping up so far? Okay, so let's say 20 years have passed. Johnny completes his mission and comes home. If Einstein's theory of special relativity holds up, then we expect the twins to look completely different from one another. John, who stayed here on Earth, experienced the effects of time pass, while on the other hand, Johnny also aged a bit, but not as much as John. It would appear that John is a much older brother, albeit having the same facial features as Johnny. Back in 2015, NASA conducted a somewhat similar study on astronaut twins Mark and Scott Kelly. It was an outstanding opportunity because, how often in your lifetime do you get twins to take the same career and work in the same place? NASA would just be crazy to pass on this wonderful opportunity. So the study went exactly as you would have imagined. One twin was left here on Earth, while the other spent time in space. The lucky one to be the sort of astronomical guinea pig was Scott, while the other one who worked in mission control was Mark. However, the goal of this experiment was not just to determine specifically if you can actually age slower in space, but to find out the effects of a human body being in space for an entire year. When Scott came back to Earth, studies showed that there were significant changes to him, physiologically and psychologically, but all of these revert back to normal after some months landing back here on our planet. Age-wise, it was revealed that despite being exposed to huge amounts of stress, radiation, and effects of the lack of microgravity, there are actually indicators that aging indeed slowed down for Scott while he was in space. Now, if you would ask me, I'd say 1 year is really short to determine any and all significant effects that space could have to a human being, if we would be able to obtain the technology to reach the speed of light. Basically, the message was Dory's litany in Finding Dory. Just keep swimming. For us to be able to achieve unwavering youth, one has to constantly move. Isn't it elegant how that makes complete sense in our lives, just in a different context? Okay, so these are all great features that seem to be achievable once we reach the speed of light. I bet the next question in anyone's mind right now is, how do we accomplish this mission the soonest? Is there any realistic way to achieve this? The sad news in all of this is that the laws of physics specifically prevents us from moving past superluminal speed. However, there is still hope. We already have the technology to accelerate particles to around 99.9999991% of the speed of light. In CERN's LHC, or Large Hadron Collider, accelerating particles to as close as they can get to the cosmic speed limit is something that they do almost every day. The goal of this is to take a peek into the fundamental parts that make up everything in the universe. Is this something that you would be interested in learning about? Let us know in the comment section below, and I'll get that video done in a jiffy. Basically, how LHC accomplishes this task is conceptually easy to understand. The collider is essentially a huge oval with a lot of magnets inside. The scientists control these magnets, turning it on and off in extremely quick succession. such that the particle accelerates at beyond breakneck speeds until it reaches about a few decimal places close to the speed of light. Now, this took a long time to develop for particles. How long would it take if we scale it up to something that we can use for space travel, right? Also, there's a lot of other issues that come along with thinking how to develop something this grand, but hey, mankind has achieved numerous fantastic feats in its around 200,000 years of existence, right? Who knows what the future holds? Maybe one of the awesome viewers of this show will be the one to finally take a crack at it and have it flying. The quest of unfolding the mysteries of this universe is a long and arduous process. If our service is to knowledge, then time shouldn't be a gigantic issue.